Are you looking to start a career in embedded software and you aren't sure what skills you need to get your first job? I get asked this question all of the time. What skills are valuable for someone looking to get a job in this field? So today I've decided to go over the most important skills to land an entry-level job in embedded software. Today, I'm going to break down all of the skills that I've used in my past jobs, various recommendations from people that I have worked with in the past, as well as some very common skills that I've seen across a lot of the jobs I've applied for. Knowing what skills are needed and are valued by employers will help you understand what skills to showcase on your resume when applying to jobs and what skills you need to work on in order to get more interviews. Let's discuss. Hello, everyone. Thank you for joining me today. I'm super excited to be here talking to you about my experience working in the embedded software field and what skills are necessary to get a job in this field. This is a topic that I'm very passionate about, so thank you for watching this video. I love talking about it so much, so this is really just means a lot to me. I just want to let you know that I do have a free gift for anyone that makes it all the way through the video. It's going to be really important for anyone who is trying to get a job in embedded software engineering and has been having a lot of difficulties getting interviews. So watch until the end of the video. I'll give you all the instructions on how to do it. Totally free gift and no pressure to take it. So these three skill categories break down into three sections. The first one is software. Based on the name, that's pretty obvious. The second one, which people don't talk a lot about, is hardware knowledge. And the last one is developer tools. That one's pretty basic when it comes to any job in software. Developer tools are super important. But with embedded, there are some skills and some tools that you'll use that are entirely different than any other software position. So without further ado, let's jump into the first category. Okay, so jumping into section number 1 for software, I'm going to mainly talk about the different programming languages that you need to know in this field. So unsurprisingly, the first programming language that you should know is C. Definitely the most important language that you'll ever use in this field. The majority of embedded code is written in C, mainly because of how effective it is at programming resource-constrained devices. So when it comes to C, there are some topics that are very important specifically for embedded software that maybe aren't as prevalent in other fields. Those being knowledge of preprocessor macros, which if you don't know what those are like the hash defines that you see at the top of files. Understanding pointers, understanding structs is also huge. Knowing what static and volatile types are is also beneficial. And understanding dynamic memory allocation is pretty important too. Now, before any of you go up in arms about dynamic memory allocation in embedded applications, the reason why I'm saying you should know what it is and how to use it is so that you understand why you need to avoid using dynamic memory allocation in embedded devices. So just learning the concepts of what it is and how it's being used, you'll be able to understand why you need to avoid it in your career. Second language that is pretty important is C++. So C++ is not as prevalent as C in embedded devices as of right now, but there are a lot of companies that are starting to make that switch from C into C++. Mainly for the reason that C++ gives C the ability to be object-oriented. And if you don't know, object-oriented programming is a very popular method of programming just because of the simplicity and the flexibility that it gives you when structuring your programs. I suggest that you should really focus on learning C first if you haven't. If you have a pretty good understanding of C, then you can start working a little bit in C++, but I recommend only really learning the basics. most embedded jobs are going to be focusing on C. And if you know how to use C, you can pick up C++ pretty quickly. And the last programming language that seems to be pretty important is Python. So some of you might be surprised by this. Python is not one of those languages that you put onto a bare metal device. However, it can be used for scripting and tool creation and automation. So I've actually used Python a lot in my past internships, specifically working on embedded teams. So we used Python to create automated testing or automated tools for various work that was extremely easy and repetitive. We could just do this so that you didn't have to put all the manual work into something that could just be done by a computer. So most people I find are familiar with Python. A lot of people have this as the first programming language that they ever learn. If you aren't familiar with Python, I highly recommend going and learning the basics of Python. It's a pretty easy language to learn, so you'll pick it up really quickly if you already know how to program in C. And I recommend learning some common libraries just because it really opens up the possibilities for creating, really quick programs or really quick prototypes when it comes to testing out logic. And now we'll move on to hardware. Hardware being our second category of skills that you need to know for embedded software. So in hardware, first and foremost, you need to know microcontrollers. The majority of your programming work is going to be programming microcontrollers, and you have to know how to program them properly and what the best practices are for writing code on them, because it's very different than writing code that just runs natively on your computer. So some important topics to learn about microcontrollers. You should know how the memory is organized on them and how changing your code can change how memory is being used. So there are different parts of memory where your code is being stored. And if you write your code in specific ways, you can actually change what areas of memory are being used. And this is very useful when you're trying to make really fast devices or really resource-constrained devices. The other really important thing you should know is how to read a pinout for a microcontroller. So if you don't know what a pinout is, basically a family of microcontrollers can all do the same thing, but they might have different package types. And what I mean by package types are different sizes of chips, different formats of these little chips that go on your boards. And all the pins that come off on the chips will all have their own specific function. Some of them might have multiple functions that they can do, but you need to know what each pin does because it can vary quite a bit between processor families, controller families. So being able to read a pinout diagram, it will tell you exactly what each pin does and which pins you're going to need to access certain peripherals. You'll often find these pinouts in the datasheets. So datasheets are also really important to learn how to read for microcontrollers, as they'll tell you some of the nuances of the specific controller that you're working with. So just getting a basic understanding of how to read these datasheets and diagrams can really help you understand and be able to translate your knowledge from one microcontroller family to another. The next thing that I think is very important to understand is interrupts versus polling. If you don't know what interrupts are, essentially they are a flag that gets set in hardware that if this flag is set, then a certain interrupt service routine that you write in code is called. So the program that you're running, the main program, is just interrupted, hence the name, and activates the service routine before returning control back to the user program. Whereas polling is if this flag is set, you actually have a function within your user program that checks this flag at a regular basis. And the last little tip that I have for you is I suggest that you pick up a development board for really any family of microcontrollers and really learn the basics of that microcontroller. You don't have to go learn a bunch of different products or a bunch of different architectures. Really focus on just one and learning the basics of that one. Your knowledge will eventually transfer over into other families and other products. So just really become familiar with one. And my recommendation is the STM32 products, just because they are relatively cheap. There is a lot of community support around programming them. They're very popular in the industry right now. So chances are if you learn how to use one, you will be using it on the job. So that just translates over very nicely. The other part of hardware that you should be learning are common hardware peripherals. And these would include like your basic GPIO, general purpose input-output pins, which are crucial for any embedded device. Basically, they run the functionality of interacting between your software and the hardware it works with. You should also learn some basic communication interfaces. This would include I2C, SPI, and UART. These are all common interfaces used in industry, and that's how you're going to be able to communicate between multiple devices or chips. And I think you should also have a pretty basic understanding of timers, hardware timers, and watchdog timers. You don't necessarily need to know how to implement these based on my experience. I've only ever been asked why you need to use them or about designs that would use them. I've never been asked to explain the technical details behind them. So just learn what hardware timers are and what watchdog timers are and why you might use them in embedded applications. And the last thing for hardware is get some basic understanding of basic electronics. Now, I've taken some circuits courses in university. So if you're in university and college and you are learning some circuits courses, chances are they are a little more in-depth knowledge than what you're going to need on the job. Going to be honest, I've taken a bunch of circuits courses and the majority of what I've learned in them, I have never used again. So specifically for embedded software, some things that you should know: voltage, current, resistance. You need to know Ohm's law. That's just super important for anyone working with electronics to understand. The next thing that's super important would be pull up versus pull down resistors. What do they do? Why are they used? That's something that you can easily look up on Google if you need. And the last thing for basic hardware or basic electronic knowledge would be how to read schematics. So schematics are basically a diagram of how circuits are laid out, all the different components and what's connected, and where voltages are, power supplies, grounds, things like that. It can be very helpful. A lot of jobs have that as like a nice to have quality for one of their candidates, but I have not really ever seen it used as a requirement. I have read schematics in pretty much every job that I've had, so I would recommend at least learning how to read schematics, how to look at them and understand them at a pretty basic level, if nothing else. And on to section number 3, developer tools. So like I said before, basically any software engineering job, you're going to have to work with some developer tools, and embedded software is no exception. The first tool that you should know is version control. And in the industry, most companies nowadays are using Git. So if you haven't learned how to use Git, I highly recommend that you at least learn how to create a repo, commit changes, create a branch, commit to that branch, and how to merge a branch into your master or main branch or whatever it's called. It's super easy to learn, and it's free to set up an account with GitHub. So I recommend you get a GitHub account if you haven't already. GitHub is not just great for showcasing your projects on resumes, but it is actually a great tool for learning how to use Git properly. Every job that I've had uses Git and basically assumes some basic knowledge of how to use Git. And there's all kinds of tutorials out there. It's pretty easy to pick up just learning on your own. The next skill that you should have is working with hardware debuggers. So if you took my advice on working with STM32s, STM32 is great because most of their development boards come with the hardware built in for their own custom debugger, which is called ST-Link. So if you are using their STM32 or STM Cube IDE, there is a built-in debugger interface that works with the ST-Link. And I highly recommend you learn how to use that because there are a lot of, basically any job that you work at in embedded software is going to have some requirement to use a hardware debugger. So just by nature of having software running on hardware, it is really difficult to debug your code and figure out what's going on. So working with hardware debuggers is typically a skill that most companies will like to see. JTAG debuggers are also very common in the industry if you're not working with the STM32 devices or the STM32 ecosystem. So some skills that you should learn is learn to check your code by running the debugger while the code is running on hardware. And you can step through it using breakpoints or just the step through, step into functions like most common debuggers have. So just learn what it's like working with that kind of debugger on a system running software on hardware. And last thing for developer tools, you need to learn the compilation process. So learn how your C code becomes assembly, or it becomes machine code. This is something that's very important just because a lot of people kind of skip this step when they're learning C. So learn what a preprocessor is, learn what a compiler does, what an assembler does, and a linker as well, and what kind of optimizations your compilers will make. So if you aren't aware, there are some things that your compiler does to optimize the code that you write. And often that can change the behavior of your code and make it do things that you weren't expecting it to do originally. So it's good to start looking into that and seeing those kinds of optimizations it makes so it doesn't end up messing up your code in the future. Also, many companies use things like CMake and Makefiles to compile their code for them. Essentially, it's just a file with a bunch of commands in it on running the compiler with different options and choosing what files to compile and which ones to link together, things like that. So not really necessary for you to learn these right away, but later on in your career, it's going to be good to know, how to write these CMake or Makefile files and how to use them properly. Okay, so just to summarize, the three main categories of skills that you need to have as an embedded software engineer are software, hardware, and developer tools. Become familiar with all of these different categories and the different technologies that I talked about in each one of them, and it'll help you a lot on your path towards starting this career. So knowing what skills are important for embedded software engineering will help you figure out what skills you need to show off to employers, what skills you need to have on your resume to get noticed, but also what skills you need to work on the side, or what other courses you need to take if you're still in university or college, so you can kind of get a deeper knowledge of some of these concepts and be able to better talk about them in interviews and show off your knowledge. Having all these skills is great, but it's not going to do much if you don't have an effective way to show them off to employers. So it's still going to be really difficult in order to get a job in embedded software. So today I've put together a free gift for you just for making it all the way through this video. I have put together the ultimate project planning guide that will tell you how to come up with the best resume project idea to show off your embedded skills in the best way possible. It is a 3-day action plan that will walk you through all of the steps that you need to create your first project step by step. And I know what you're probably thinking. you've got a really busy schedule and it's going to be hard to work on a side project while you're doing everything that you need to be doing right now. Well, what if I told you that this process only takes 30 minutes a day? Pretty sure that you can spare 30 minutes a day. This guide is perfect for students who have a busy school schedule right now and are looking to level up the style of their resume projects. So if you want the guide, just go down to the description and click on the link. It'll bring you to my webpage where you just need to enter your email address, and then you'll be able to download the guide right from there. It's completely free, so go take advantage of it right now. Thank you so much for watching this video. If you have any topics that you want me to cover on embedded software careers, or any kind of topics that you're kind of confused about in embedded software, let me know down in the comments. If you have any questions related to the video today, ask them down there as well. I will answer every question that I see that pops up there. And if it's a good enough question and I feel like a lot of people are struggling with that problem, I'll probably make a video in the future answering that question. So thank you so much for watching today, and I will see you next week.